Now we're going to look at adding vectors. And in the specific case of this, we're going to talk about colinear vectors. Now it sounds like a pretty fancy word, colinear, but it's actually fairly straightforward. What do I mean by colinear? Well, colinear means they are both pointing along the same line. So for example, both these vectors are pointing to the east. Okay, or they could be one pointing to the east and one pointing to the west. But when I go to add vectors, what I need to do is put them tip to tail. And so if this is my first vector, and it's 13 meters, let's write that down, 13 meters. And let's remember that since it's a vector, we want to keep track of direction. So we're going to say 13 meters, and the direction in this case is east. How do I know it's east? Well, because I always remember to put a little indicator saying what is my standard. And my standard is usually north pointing up, but you need to remember to put it there. And yes, I will dock you marks if you forget to tell me what your frame of reference is, because frames of reference are important. Here's my second vector, and that one we'll say is 15 meters east. And when we represent these vectors with arrows, we want them to be roughly to scale. They don't have to be exactly to scale, but certainly 15 meters should be longer than 13 meters, but not a lot longer. So when I add these two together, what is my result? Well, the first thing I'm going to do is represent my result with an arrow. It starts at the tail of the first vector and ends at the tip of the second vector. And so what is the result here? Well, that result is equal to 13 plus 15, 28 meters. And what's my direction? East. So notice, very straightforward, it just ended up being the addition of those two vectors as if they were scalars. Okay? Now, we need to pay a little bit of attention to direction. Remember, the vector has a direction as well as a magnitude. So let's look at the next example. Let's look at these two vectors down here. So here's my first vector. We'll call it vector 1. And here's my second vector. We'll call it vector 2. So to add these two together, what do? I put them tip to tail, like so. So that the tail of the tip of vector 1 touches the tail of vector 2. Now we can see the resultant if I represent it the way I did before. Remember, I start at the tail of vector 1 and I go to the tip of vector 2 and I get the resultant. And you can see it's a small value. Now how does that happen? Well, let's consider our two vectors. Our first vector is pretty similar to the one up there, so we'll say it's 13 meters and what was the direction? East. And we've added to that a vector which is, I don't know, let's say it's about 9 meters, but its direction isn't east, is it? It's pointing west. So let's indicate that. Now I can't simply add these two together. It doesn't make sense. I know my resultant needs to be a small value. So let's think this through. You've got 13 meters east plus 9 meters west. So my resultant here, oh, well, let's think this through. These are not the same. Notice that, and this is one of those critical little details. Okay, here we have east, here we have west. We can't add them together like that. So what do we need to do? We need to change one of them so that the directions are the same. Now, in the case of colinear vectors, that's quite easy, because west is simply negative east. So let's just change that. So 13 meters east plus negative 9 meters east. What have I done? Well, what I've done is fairly straightforward. I've taken the negative east to represent west. They are equivalent. If you think about it, east is the opposite of west, so negative east must be also west. Think that one through if you're not quite sure about it. So now that I've rewritten it this way, what do I have? I have 13 meters east minus 9 meters east. And what does that equal to? 13 minus 9 is 4 meters. And my direction is east. And it is the convention to give the final answer for a vector as a positive number. This is also equal to, you could come up with the answer if you did it in the opposite direction. If you used west, you could have ended up with the answer minus 4 meters west. And it does represent the same vector. But because the convention is to write it as a positive, even though that's right, it's not the way we represent it. It's kind of like wearing socks with sandals. We just don't do that.